Okay, here's a just a kind of the Reader's Digest version of the Big Bang Theory, and I want to kind of explain this as it applies to apologetics. Basically, it's kind of ironic when I've explained this to my students. It tends to offend a lot of people that are believe in God or creationism. And I try to assure people that there's nothing about the Big Bang Theory that's offensive to theism. As a matter of fact, it's probably the most singly supporting thing that a theist has in an argument. So definitely, I want to encourage people to kind of embrace this view, as it does our worldview quite a bit of justice. Basically, what the Big Bang Theory is what scientists now believe is 13.7 billion years ago. The universe came into existence from a singularity. Now, what a singularity is, it's a infinitesimal point size that has no volume. It's what scientists believe that black holes are also singularities. Their event horizons could be huge, but the object, the black hole itself, has no volume. It's infinitesimally small. That is because gravitation, by Einstein's theory of general relativity, is affected by gravity. So when you have a large amount of mass, the lines of space are pulled in so tight that there is basically no volume. And that's the situation you have at the beginning of the universe. Very quickly, this expanded. But here's the concept that gets really tricky. People kind of think of the Big Bang as something that it expanded into space. That is a kind of a misnomer, incorrect assumption. Before the Big Bang, space didn't even exist. Time didn't exist, and space didn't exist. Now, this would seem absurd before Einstein's general relativity, or special relativity, for that matter, because before that, philosophers and scientists considered time a constant, almost a human construct, not something that is affected by gravity. It's not something that is flexible or bendy, so to speak. But as Einstein showed, and many experiments confirm this, that time is indeed flexible, and space is also flexible, was also confirmed, and that's what made Einstein famous, was this confirmation that space was bendable. In other words, the shortest distance between 2 points might not necessarily be a straight line if there's a gravitational field. Now, to the person that would be traveling to this to these 2 points, they would believe they were traveling in a straight line, but to an outside observer not affected by the gravitational field, they would see this line as being bent. So I just wanted to point that out to show that science, or at space and time, is a very flexible medium. It's not something that's static, or in a kind of a classic sense of space and time that the Greeks would have talked about. Moving forward, basically this at the beginning, when there was the Big Bang, space. So you have space and time expanding into nothing. It's not expanding into more space. It's expanding into nothing from nothing, from the purely naturalistic point of view. Then, as time progressed, the universe continued to expand, and is cooled off, and energy condensed into matter by way of E equals mc squared. Well, Einstein showed there was a interconnectivity between energy and matter, that one could be changed into another, that neither one could be created or destroyed, but they can change from one form to the other. In other words, you can view matter as frozen energy. That's probably the best explanation or analogy that I can use. Let's see. Now, as far as lines of evidence for this, and this is something that I share with my students, is that the strongest, the first line of reasoning, or the first line of evidence, was discovered by Edwin Hubble back at the beginning of the last century, around the 20s and 30s, around that time frame. He was working at the Mount Wilson Observatory and observing distant galaxies, and he noticed that all these galaxies appeared to have their spectral signatures shifted to the red side. Now what that means, in more layman's terms, is if you have an ambulance pass by, you'll hear the siren pitch go up as it's coming closer to you, and the pitch will move down as the ambulance moves away. Well, in the same way, starlight, if a star is moving towards us, the starlight will be blue shifted. If the star is moving away from us, the spectra will be red shifted. It'll be moved to the red. And he observed that all these galaxies were on average, were all moving away from us, especially and he also observed the more distant the galaxy, the more extreme the redshift. In other words, the furthest galaxies were moving away faster. Now, the only way that this could be is if they all had a single point of origin. Now, we're not necessarily at the center of it, but even if you can imagine being off center of an expanding mass of dots in kind of a volume, a spherical sense, the galaxies being scattered within the sphere. If you imagine yourself anywhere in that sphere, it doesn't have to be in the center. You would be able to see that all these galaxies are moving away as the sphere expands. And what scientists are finding out is that not only is it continuing to expand, that it's actually accelerating, and that's where dark energy comes in. That's a whole nother topic. I'm not going to get into it further. So Edwin Hubble's discovery of the redshifted galaxies was the first clue that we evolved from a single point. The second line of evidence is the cosmic microwave background radiation. Now, this is basically, in layman's terms, it's kind of the echo of the Big Bang. It's all the energy, the energy that didn't coalesce to form galaxies and stars and whatnot, continued to spread out throughout the galaxy, and the remnants of this radiation or re-radiation is in a very cool, I believe it's 2.7 Kelvin. I'm sure someone will correct me if I'm wrong. Basically, black body spectrum that is irradiating from pretty much evenly distributed throughout the whole universe. Now, the Big Bang Theory actually predicted the cosmic microwave background radiation, and scientists have since then found it and found that its temperature is exactly pretty much what the Big Bang Theory predicted. And also, in order for galaxies to form, the cosmic microwave background radiation has to have some basic irregularities to it. It can't be perfectly smooth, or galaxies would never be able to coalesce and form. And they've found these differences, these necessary differences. It's subtle, but physicists or astrophysicists have been able to find these and study these and see that they also agree with the prediction and what's necessary for galaxies to form and superclusters of galaxies. So that's my version of the Big Bang Theory, just kind of a nutshell version. And if you have any questions, feel free to respond or post.